Okay, I think we only have one example left to go over because we had discussed the following families: an alkene, an acid, an ester, an ether, an aldehyde. Did I say ketone? No. And there's just one left. Okay, and it's somewhat of a review. So if we had only gone up to this point, what functional family would we believe that to be? It's an alkane because it's only carbon and hydrogen. And what's true about the bonding in that carbon and hydrogen? It's single bond because it's double, it's an alkene. If it's triple, it's an alkyne. All right. But what was different about this from yesterday, is that in chlorine is in column 7 of the table, and anyone remember what column 7 is called? You're right. Yeah, it's a halogen derivative because chlorine's in column 7. Okay, so there are two ways that we can name that. You can say we've got this halogen derivative as chloropropane. Okay, that would be acceptable. Or does anyone remember what because we're going to be going over these different derivatives here in just a moment. Does anyone happen to remember what this guy would be? Yes, this is still an alkane, but we got something branching off of the parent chain. A one carbon derivative. Does anyone have to remember what that might be? Starts with an M. It's not methanol. Okay. So, tell you what, we'll come back to that. Okay. So for right now, we would just call that chloropropane. All right. So if you do not remember your names for prefixes for 1 through 10, maybe you want to write that down. 1 hydrocarbon alkene is methane. 2 is ethane. So we can write them out. Okay, go ahead and do that here. Remember, 1 carbon is methane. So if we go up to 2 carbons, we know that is ethane. Okay. So what about 3 carbons? Propane. Okay, so that's propane. Okay, what about 4 carbons now? And that's butane. Okay, and once you get past number 4, the prefix is the geometrical shape of the number of carbons. In essence, what we mean by that, if we go up to 5, that would be pentane. That's right. Okay, so you add 1 on, 1 past pentane is, of course, hexane. 7 might be a little difficult. Heptane, that's right. Then, of course, a stop sign, octane, nonane, and decane. That's right. Is that from last year? On the back of your periodic table?
No, mine's on a piece of paper.
Oh, okay. Well,
I have my physical science one too.
Yeah. When Berger had taken this class, he said, I still have all my materials from this class. Would maybe help, maybe yes, maybe no. But maybe the problem that could arise from that is as you are maybe looking at some of that material, does it ring a bell about, oh, I remember this, now, oh, I remember this, or you look at any of it and say, I don't know. Very good. All right. So, we are just going to go over two derivatives. And I got some papers for you to do on Tuesday. The rest of the time will be yours. Okay? And I'll say work on them, don't work on them. It's entirely up to yourselves, right? You want to utilize that time. So, if something is derived, for instance, what is sometimes, well, you can also use these elements on the periodic table. Of course, when you're looking at these elements and you're looking at the names and comparing them to the symbols, you look at it and say, that makes absolutely no sense. For instance, of course, bromine makes sense because it's Br. Carbon makes sense because it's C. Hydrogen, same thing, H. But what might be an example of an element that has a symbol, iron? So, if you remember, why do we call iron Fe? None of us speak Latin in here, though. That's the problem. The Latin name for iron is ferrous. Okay? So that's why we see Fe for iron. Of course, that's not the only one that you would pick out. Maybe could be these two guys here, sodium and potassium, or some other examples. But they come from the Latin name. That's what we're trying to explain. They're derived from that. That's where they come from. So, with these derivatives, the names.
The athletic trainer is here if you'd like to see him. The athletic trainer is here if you'd like to see him.
Well, until we get to a regular schedule, that's probably how it's going to be. Just show up as needed. We probably wouldn't stop. There must be a need for him to stop. Because you're right, he was here once already. You know, I'm guessing next week he'll be here on Monday and Thursday. And then, of course, the following week after that, probably Tuesday and Thursday. And then we'll eventually get on that Monday, Thursday, Monday, Thursday, Monday, Thursday. Okay. So keep in mind that methane is CH4. There's our molecular formula. Here's our structural formula way out here. But if we talk about this guy instead, CH3, or commonly known as this, so what I'm putting inside the box here, I'll say there's our X. Here's our X up here. So we see the same thing over there. So we know that CH4 is methane, but we are not dealing with methane anymore. We're dealing with CH3. So the name of this derivative is derived from methane. Just like ferrous, the Latin name for iron is derived from the Latin language. So it just means where it comes from. So if this is methane, now do we maybe remember what this also starts with an M? It sounds very similar to methane. It's a methyl group. The term methyl is derived from methane. Okay, so we would do the same thing with ethane, C2H6. We got our molecular formula. Here is our structural formula. But in this case, C2H5, or let's say X marks the spot. Okay, so we got 2 carbons, 5 hydrogens, 2 and 3 gives you 5. So if C2H6 is ethane, C2H5 is derived into this name, ethyl, and that continually repeats itself. Methane to methyl, ethane to ethyl, propane to propyl, butane to butyl. Okay, so the derivative is derived from the parent alkene. All right. So the last thing we want to go over. Is anyone confused over this? The methane, methyl, ethane, ethyl. Okay. So we're going to spend just a brief amount of time on naming these alkanes, and then we'll be done for today. Well, whether you choose to work on these is up to yourself. So the first thing that we want to do is find our longest continuous parent chain. Okay, and how many carbons would that be? 4. Now there's 2 different ways you can come about that. You can say the most common is 1, 2, 3, 4, or you could say 1, 2, 3, 4. But remember, these compounds don't necessarily just go from left to right. They can also go right to left. Okay, so one of the things that we had taught you, I believe, or had illustrated, there's nothing wrong with going 1, 2, 3, 4, even though there's nothing out there, and then going back the other direction, 1, 2, 3, 4. So I don't know if you can see that. Do we go by the orange number or the purple? I should say the top or the bottom numbers in here. The top one. Because if we're going left to right, this is on number 2. If we're going from right to left, it's on number 3. So anytime you're thinking of the sports, not only just golf, but also cross country. Does anyone remember how they score points in cross country? I don't know if you would have remembered. Say that again. The lowest. So yeah, whoever comes in first, that's just 1 point. So whoever has the lowest total points, then kind of a little strange, isn't it? I mean, let's say you had 50 runners come in first, and then you get 50 points. You know, it's just like golf. The lower point totals you have, the better. So that's what we're visualizing here. Think golf. You just have to compete in a varsity meet. Yep. Okay. So what is our parent chain called? 4 carbons. It's called butane. Okay. Is there anything branching off of that butane? A methyl group. And where is that methyl group located? 2. Okay. So dashes separate numbers from letters, and commas separate numbers from other numbers. We don't have that example here, but if we did, if we had another methyl group up here, we would say 2, 2. It's the commas that separate the numbers. Nothing too complex yet. Okay. So the paper that I'm handing out, it just says categorize or classify the organic compound as a ketone, as an aldehyde, or an ester. You don't have to name them, but some you will have to classify as an alkane and then name it. So again, if there's any questions over that, feel free to ask. And again, you have time to work on these on Tuesday. I will collect these, and then next week we'll get the journal going. Well, nice to have at least 3 sentences, something to that effect. Okay, so I'm going to be the stapler. Work on these, don't work on them. You have the rest of the time to utilize how you see